Hello friends, we have discussed black holes multiple times before. It is well known that if anything crosses the event horizon, be it an asteroid, comet, planet, star, or even light, it is never able to escape. This suggests that while we have a decent understanding of what occurs outside a black hole, we lack any means to see what happens within. However, there are several speculative theories. If you try applying some logical reasoning and imagine what could exist inside a black hole, it's actually quite simple. Pause the video for a moment and look around. Still confused? Well, based on this theory, our entire universe might be situated inside a black hole. Seems unbelievable, right? Check out this research paper. In 2014, American scientist Nicodem Poplawski proposed that our universe could indeed be inside a black hole. I know this may sound like a wild claim, but let's dive deeper and uncover the truth. To begin, let's go over a fundamental concept. How exactly is a black hole formed? I realize I've explained this before, but let's do a quick recap. Within the core of every star, there is a continuous struggle between nuclear fusion and gravity. Essentially, nuclear fusion reactions generate energy, which works against gravity's inward pull. However, once a star exhausts its fuel, there is no remaining energy to counteract the force of gravity. If the star is sufficiently massive, it collapses upon itself, creating an extremely dense point which results in the formation of a black hole. Now we know that at the heart of each black hole is a singularity, a point with infinite density and zero volume. Scientists believe that everything falling into a black hole merges with this singularity. However, this isn't the only singularity that exists. There is another known as the Big Bang singularity. As I've mentioned before, our universe is expanding with everything moving farther apart. However, in the 1960s, Stephen Hawking imagined reversing this expansion. He realized that, at some point in the past, all matter must have been compressed into an infinitely dense and tiny region. Essentially a singularity. Does this suggest a connection between black holes and the Big Bang? The challenge here is that, while a black hole's singularity draws matter inward, the singularity from the Big Bang pushed matter outward, causing expansion. These seem to be polar opposites, so, is there any way to compare them? Not directly, but there exists another celestial entity that might bridge this gap, a white hole. A white hole is essentially the inverse of a black hole. While a black hole pulls in matter, a white hole expels it outward. Entering a white hole would require traveling faster than the speed of light, which is impossible. Interestingly, mathematical models indicate that white holes also contain singularities. Could it be that our universe originated from the singularity of a white hole? If so, where did the matter inside this white hole originate? According to certain theories, black holes and white holes may actually be connected via their singularities. This would mean that the same singularity responsible for pulling matter into a black hole also pushes it outward through a white hole. This implies that the material collapsing into a black hole might end up forming a new universe on the other side. This concept is the foundation of the theory of baby universes. In 1992, physicist Lee Smolin proposed a hypothesis in his book The Life of the Cosmos called cosmological natural selection, also referred to as the theory of baby universes. According to this hypothesis, any object crossing a black hole's event horizon becomes a part of its singularity. Over time, as more matter accumulates, the singularity's mass increases. When it surpasses a certain threshold, it undergoes an enormous explosion, leading to the birth of a new, daughter universe. This new universe would be separate from its predecessor, initiating its own cycle of formation. It would create its own stars, solar systems, galaxies, and black holes. These black holes, in turn, would give rise to even more new universes, continuing the process indefinitely. If this theory holds true, then within each black hole, there may exist an entire universe. In fact, the black holes we have photographed might themselves contain entire universes within. This also raises the possibility that our own universe exists inside a black hole. British scientist Sir Roger Penrose provided both mathematical and graphical validation for this theory back in the 1950s, using his Penrose diagrams. These diagrams might appear complicated, but let me simplify them for you. Typically, to determine an object's position, we use a two-dimensional or three-dimensional graph. A three-dimensional graph helps pinpoint an object's location in space, but to track when an event happens we must add another dimension, time. Since humans exist in a three-dimensional reality, visualizing a four-dimensional graph is challenging. However, mathematician Hermann Minkowski devised a way to translate space and time into a two-dimensional graph, now known as the Minkowski diagram. In this model, all three spatial dimensions are combined into the x-axis, while time is represented on the y-axis. In such a system, light always travels at a 45-degree angle, signifying that nothing can exceed the speed of light. Now, let's introduce a black hole into this framework. As we approach a black hole, its gravitational pull draws us inward, bending the paths of light. Consequently, our light cone tilts and shrinks. Upon crossing the event horizon, the entire light cone is confined within the black hole, eliminating any possibility of escape. This explains why even light is unable to emerge from a black hole. Scientists needed a more practical way to visualize this, which is where Roger Penrose came in. To maintain the symmetry of light cones despite space-time curvature, Penrose adjusted the graph's axes. You might remember the old saying, "Parallel lines meet at infinity." Penrose leveraged this concept to design a graph in which light cones remain structurally intact, making it easier to grasp. Through this approach, he mathematically demonstrated that an entire universe could indeed exist inside a black hole. Even more astonishingly, this theory hints at the possibility of a multiverse. But as fascinating as this theory may be, fully understanding it is no simple task. However, I hope I was able to explain it to you in a way that makes sense. If you found this video interesting, don't forget to like and subscribe to our channel.